Another video for mathematical induction. In this video, you're going to prove that n factorial is greater than 2 to the n for all n greater than or equal to 4. So the solution goes like this. We first let Pn be the statement n factorial is greater than 2 to the n. Why should we do this? Letting Pn to be the statement makes you reduce labor for you of writing of writing this entire statement. Instead of writing this entire statement, you can just call Pn in the proof. So if you are just saying Pn in the proof, you'll be meaning that n factorial is greater than 2 to the n. So that is Pn is just meaning the statement in terms of n. So the left hand side, so for this case, we were actually told that our n is starting from 4 going upward. So for n equals to 4, you can actually see that the left hand side will be equal to 4 factorial, which is equal to 4 times 3 times 2 times 1, which is equal to 24. And the right hand side would be 2 to the power of 4, which is equal to 4 times 4, which is equal to 16. Therefore, you can actually see that the left hand side of Pn. Okay, so let's just say the left hand side of P4 here so that it will make sense. So the left hand side of P4 is like that, right hand side of P4. So since you can actually see that 24 is greater than 16, therefore P1 holds P4, sorry. I'm fond to doing the P1s. For n equals to 4. Perfect. So then the next stage is for the inductive assumption. So we assume that Pn holds for some n which is equal to k. Then that implies that Pk is such that we're now putting k wherever there is n, so we have k factorial is greater than 2 to the k. For k greater than or equal to 4. So the next stage is this one is just the inductive hypothesis. Then the next stage we are going to consider the left hand side of P k plus 1. We should get to the right hand side after the proof. So we have k plus 1 factorial being equal to k plus 1 times k factorial. I know others might ask why. We know that since let's take, for example, if we have 5 factorial, it is equal to 5 by 4 by 3 by 2. But then you can see that 4 by 3 by 2 is 4 factorial. So it will be 5 factorial by 4 factorial. So generally, if we have now k plus 1 factorial, it will just give us k plus 1 times k factorial. So that's how we got this. And then we know that since we were actually told that k is greater than or equal to 4, k is greater than or equal to 4, this one is simply greater than 4 plus 1 by k factorial, which is greater than 5k factorial. And also, since we know that k factorial is greater than 2 to the k, we have this one being greater than 2 to the k. So we now have 5 by 2 to the k. And as a result, we now have, since we know that 5 is always greater than 2, if we multiply both sides by 2 to the k, by 2 to the k, we just get that this thing is greater than 2, which is this one is greater than 2 to the k plus 1, since this one is equal to the k plus 1. So you can actually see that k plus 1 factorial is actually greater than 2 to the k plus 1. Therefore, Pn holds for n equals to k plus 1. Therefore, by principle of mathematical induction, Pn holds for all n greater than or equal to 4. Perfect. That's the solution for this one. We are going to move to another example.